Hello and welcome to this video. Today we are going to look at electrolysis of a solution of copper to sulfate. Remember, during electrolysis, we basically pass electricity through an electrolyte. However, in this case, take note, we are going to use graphite electrodes and it will do the same work as platinum electrodes. We shall not use copper electrodes. One thing to note about copper to sulfate, we all know that whenever we add water to anhydrous copper to sulfate, we shall form a blue solution. So our copper to sulfate is actually blue. All we need to do is to put some rods in this solution, and then we try and connect it to a battery because we are planning to pass electricity through it. So let's have a look at a similar setup where we have put our graphite electrodes into our copper to sulfate solution. But take note, it's blue if at all water has been added to it. So here's our simple setup. We have our battery here, our DC supply. And when you look at this setup, that means that the positive terminal is this long terminal here, while the shorter one is the negative terminal of the battery. So that means when you look at our setup, we have our carbon electrodes, the ones we have called for graphite, because it's graphite which will be able to conduct electricity. Diamond cannot do so. So in this case, we have to use the carbon electrode in the form of graphite. So this is the setup. We have our electrodes dipped into our blue copper to sulfate solution. So once we close our switch, that means we shall induce these electrodes to become charged relative to one another. When you look at the electrode that has been connected to the positive terminal, it will become positively charged. And that means this will be our anode. Remember, in electrolysis, the positively charged electrode is the anode, while the negatively charged electrode that has been connected to the negative terminal of the battery will be our cathode. Now, one thing to note about copper to sulfate is that whenever it is in solution form, we shall always be having copper 2 ions present together with the sulfate ions. So in our solution, this blue solution you see here, we shall always be having positively charged copper 2 ions and negatively charged sulfate ions. However, because it is a solution, as you can see here, that means there is some water present. And we all know that water can actually also slightly ionize into the hydrogen ions plus the hydroxide ions. So that means in our solution, we actually have some hydroxide ions and then some hydrogen ions as well. So what does this mean? It means in our liquid part of the copper to sulfate, or in our beaker, if at all this is our beaker, that means we shall be having 4 different types of ions moving around. And in this case, whenever the switch is closed, we shall have the negative electrode and the positive electrode. So what happens? We all know that opposite charges attract. So we shall see our positively charged ions in solution moving to the negatively charged electrode. So that means our positively charged, the copper 2 ions, will move towards our cathode together with the hydrogen ions because our cathode is negatively charged. However, the sulfate ions will also migrate towards the anode due to attraction of these opposite charges. So in this solution, these ions are moving towards the opposite electrodes. And in this case, what happens? Let's take an example. We'll start with our cathode. What happens at the cathode? So at the cathode, we have 2 ions which will arrive. Remember, our cathode is negatively charged. So that means the ions that will arrive will be the hydrogen ions and the copper 2 ions. So obviously, both of them will be discharged, but to a greater extent, one of them will be discharged in preference to the other. So we usually use electrochemical series. As you can see here, we have our electrochemical series for the cations. So those that are lower in the electrochemical series of these cations will easily be discharged. So if you look at our hydrogen ions together with our copper 2 ions. So copper is lower in this electrochemical series, and that means when both of the copper 2 ions and hydrogen ions arrive at the cathode, it will mean that mainly copper 2 ions will be discharged, and as such we shall have our copper 2 ions. If we write this in form of our equation, this is aqueous. When it reaches a negatively charged electrode, our cathode, it will have to pick 2 electrons. It will actually pick 2 electrons because it's becoming discharged. It is lacking 2 electrons and the cathode is reaching electrons, so it will pick 2 electrons and then it will be converted into the copper atom, which will now be a solid. So as you can see, this solid can easily be seen being formed underneath this cathode. And this is the brown solid we may see in our beaker with time. So this is the discharge that occurs at the cathode. Copper 2 ions are preferentially discharged in respect to the hydrogen ions. However, when you look at our anode is the positively charged electrode. And that means these negatively charged ions will migrate to our cathode because they have different charges. So we also have a series that can help us identify which negatively charged ions can easily be discharged. The ones below in this series will always be discharged. So we have the hydroxide and the sulfate ions. So obviously the hydroxide ions can easily be discharged. This is like a football maybe table. You have teams at the top and those below. So there is kind of hierarchy in terms of gain of electrons or loss of electrons. So in this case, our hydroxide ions will be discharged. So what actually happens is that the hydroxide ion, when it reaches the positively charged electrode, which is our anode, in this case, instead of, because it's electrons that flow, it will have to lose an electron. But we don't prefer writing a minus to show loss of an electron. So we usually just prefer adding. So what happens, we tend to form an equation like this. The hydroxide ion will lose an electron to form the OH. This could be our primary equation. However, it's not stable, so we rarely write it. However, we get 4 of these coming together. We shall get 4 hydroxide ions, and they will lose 4 electrons. They will lose our 4 electrons. Actually, these are 4 hydroxide ions, losing 4 electrons, and then forming water and oxygen gas. So this is a liquid, and this is, so balancing 4, 2, shall put here 2. So this is the equation that will take place at the anode, because hydroxide ions will be discharged in preference to the sulfate ions. So what actually happens after us coming up with these 2 equations? Let's try and summarize what we might observe. So when you look at our setup, we have already said this is blue. But after a long period of time, this reaction taking place, we shall notice that what was causing the blue appearance of our copper 2 sulfate solution are the copper 2 ions. But because these copper 2 ions are being changed into copper solid, as we had seen previously, and they will be deposited at the bottom here, that means that the copper 2 ions that are causing the solution to appear blue are being removed. So actually what will remain in our solution will be the hydrogen ions together with the sulfate ions. because these ones will not be discharged, and the due process shall end up forming our sulfuric acid. And we all know that sulfuric acid is actually a colorless solution. So we shall see our blue solution in the beaker turning colorless because of the removal of the copper 2 ions. So basically this is what happens, and then over time obviously the bulb will stop lighting because the solution will no longer be able to conduct electricity when the chemical reactions have finally stopped. And maybe lastly, as we had seen at our positively charged electrode, we had said that we shall form oxygen gas. Or if you remember, we are forming oxygen gas. We can have a look at it. This is the oxygen gas here. And whenever you have a gas being formed in a liquid, usually we see it in form of bubbles. So we may see some bubbles of a colorless gas. This is under observations. We may see some bubbles of a colorless gas. That obviously relights a glowing splint because it is oxygen. So basically that's electrolysis of copper 2 sulfate solution using graphite electrodes or platinum electrodes. In this case, we are using graphite or platinum because these are inert electrodes. Some of the things that can affect the products of electrolysis is the nature of the electrode. Because if we are to change and use copper in both cases, instead of using carbon, actually, trust me, we shall get totally different results. That's why we are emphasizing, in this case, we're using inert electrodes like graphite or platinum. So that's all about electrolysis of copper 2 sulfate. We have seen the products being formed, oxygen gas is being given off, and a brown solid in form of copper is being formed at the cathode. Thanks for watching. Don't forget to like, share, or comment in the comment section below. See you.